Okay, so part 3b is where we're going to solve rational equations with variables in the denominator. Now, 3a was the same thing, except in 3a, the focus was on where all of the denominators had monomial factors. So, remember, all these denominators were monomial factors. So, in this lesson, at least one of the denominators will not be a monomial factor. Okay, so for example, let's go ahead and let's suppose we want to solve this equation. We have 8x divided by x minus x plus 1 equals 4. Oops, okay. Let me go ahead and rewrite this. So number 1, 8x divided by x plus 1 equals 4 minus 8 divided by x plus 1. Okay, so now notice that the denominators, see this factor right here is x plus 1. If you rewrite this as 4 over 1, that factor is a 1, and this is an x plus 1. Okay, so remember, first thing you want to do is look for your restrictions. Okay, your restrictions, and only look at the denominators where there's a variable in the denominator. So for example, over here there's a variable in the denominator. Over here there's a variable. Now let's kind of review something in a previous course. First thing you always want to do is factor your denominators. So in the previous lesson, these were monomial factors. So since these were all monomials, we didn't factor. We just set each of these equal to 0. So now we're at a situation where the factors are not monomial. So the first thing you want to do is to factor your denominators if you can factor. So x plus 1, the GCF is 1. There's no way we can factor this. So, and this is the same one as well. So all I got to do now is set each of these, well, they're the same, so just set one of them. Set one of these equal to 0 and ask yourself, where is x plus 1 equal to 0? When is this denominator equal to 0? And all you do is just solve for x. So I'm going to subtract 1 from both sides, so I get x to be negative 1. So when x is negative 1, check yourself. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. And we don't have to check this because this denominator is never going to be 0, it's always going to be 1. So the restriction is that x cannot equal a negative 1. That's your restriction. So find out what makes the denominator 0, and then that's your restriction. So when you solve all of this, and you get x to be a value, then you always want to compare it to your restriction. Okay, so I'm going to go ahead and rewrite this over. So 8x divided by x plus 1 equals 4 minus 8 divided by x plus 1. Just like the previous section, okay, you want to find the LCD. Now remember, to find the LCD, you got to factor first. So factor first before finding the LCD. All right, so x plus 1, there's nothing I can do there. It's prime. There's nothing you can do there. GCF is 1. It's a linear factor, so there's nothing you can do. Now, just remember before, in the previous lesson, once you found the LCD, in this case, remember it was 4x, then you multiply both sides. You multiply both sides by 4x. So that was this. So remember, you also put parentheses whenever you needed to put parentheses, and then you use distributive property. So same thing here. So my LCD is going to be just the factor x plus 1. So now once you find the LCD x plus 1, then you're going to multiply both sides by x plus 1. Multiply both sides by the LCD. So this is just one fraction, so I'm not going to use parentheses. And the numerator is just a monomial, so I'm not going to put parentheses in the numerator as well. So I'm just going to say 8x divided by x plus 1 times x plus 1. So I'm going to multiply the left side by the LCD, which is x plus 1. Now, on the right side, I have two fractions. So I'm going to go ahead and put that in parentheses. So 4 minus 8 divided by x plus 1. And then I'm going to multiply by x plus 1. So remember, the whole idea is to clear your denominators So clear your fractions. So you multiply both sides by the LCD. So the left side by x plus 1, the right side by x plus 1. All right, and then you're going to distribute, just like you did before. So always compare to what you've done. So you distribute, you distribute, you distribute. Okay, so every fraction, just as before, is multiplied by the LCD. Okay, so I'm going to go ahead and rewrite this over. So the LCD times the first fraction equals the LCD times the left side, or the right side. Okay, now you can distribute over here. So all of this is going to multiply by x plus 1. Now be careful, because in the past, if you look at these lessons dealing with this topic, the LCD was always a monomial. It was 4x here. It was 2x here. Previously, over here, it was 24. So it's always a monomial. Now we're at a situation where it's not a monomial, but in this case it's a binomial. So you have to be careful in some situations. Okay, so we're going to go ahead and reduce if we can. So we can here. The whole idea of multiplying by the the LCD is to get these denominators to be a 1. So I need this to be a 1. I need this to be a 1. So the x plus 1's divide out, and so you get 1 times 8x, which is just 8x, equal. All right, now, be careful here. X plus 1 has to be multiplied by 4. So you need to say this. You need to say what's really happened mathematically is this. X plus 1, in parentheses, has to be multiplied by 4. That's what this is. This times this is this. So you need to put that in parentheses. You need to put this binomial in parentheses because both the x and the 1 is being multiplied by 4. Okay? Minus. And then x plus 1, and put that in parentheses. So x plus 1 times that second fraction. Just like this. Okay? All right, so x plus 1 times 4, x plus 1 times a negative 8 over x plus 1. Now what I can do here, in this case, is these x plus 1's divide out. So whenever you have these fractions, these denominators, at some point, verify that you are able to reduce those, to divide those out, to get a 1 in the denominator. So notice over here, this x plus 1 became a denominator of 1 right here. This x plus 1 became a denominator 1 over here. So it has to be multiplied. If that's going to be a 1, I've got to divide it somehow into that LCD. All right, so now what's going to happen is this. I have 8x equal. Make sure you see how I'm aligning all the equal signs? Make sure they're aligned. And then you can distribute the 4. So 4 times x is 4x. 4 times a positive 1 is a positive 4. Minus 1, this is a 1. And 8 over 1 is 8. So 1 times 8 is 8. So I get 8x equal, combine like terms. A positive 4 and a negative 4 is a negative 4. So you get 4x minus 4. Subtract. Okay, now remember this is linear. So I went from a rational equation. This is a rational equation. Remember your rational equations. In the notes, a rational equation is an equation containing one or more rational expressions. So these are all rational expressions, one or more. And so this is called a rational equation. It's not linear because the variable is located in the denominator. And so this rational equation right here became a linear equation. So I have this linear equation. So I'm going to solve this linear equation. To solve a linear equation, remember, you're going to do these little steps here. So we're at this point, we're at that second part right here, where we bring all the variables to one side, constants to the other. So I'm going to subtract 4x on both sides. And so 8x subtract 4x is 4x, equal. 4x minus 4x is 0, and I'm left with a negative 4. Not a positive 4, but a negative 4. And then to get x by itself, remember right now I'm dividing by a positive 4. The opposite is to divide by a positive 4. So 4 divided by 4 is 1. 1 times x is x. So I get x to be, and then negative 4 divided by 4 is a negative 1. Now, notice I got this negative 1. So this equation, this rational equation, I'm saying the proposed solution is a negative 1. But remember, you had a restriction. The restriction is negative 1. So I can't say that's a solution because that's not the solution. Make sure you understand why that's not the solution. I'm going to go on the next page and say that. So make sure you understand why is negative 1 not a solution. Okay, so remember, you've always known that you can never divide by 0. So if I substitute negative 1 into this equation, if I check this, and I go back to the original problem, I'm just going to rewrite the original problem over. Negative 1 will make this denominator 0. So when I plug in negative 1, here's what I get. I get 8 times negative 1 divided by negative 1 plus 1, and I want to see if that's going to equal 4 minus 8 divided by negative 1 plus 1. Well, the numerator is a negative 8. And then the denominator, notice right away, that's a 0. And right away, you know you can't divide by 0. So that's undefined. Remember, that's undefined. So you can't divide by 0. You didn't have to do all this. You could have looked right away and said, well, first of all, I don't care what the numerator is. I'm dividing by 0 because negative 1 plus 1 is 0. So that can't be. So negative 1 cannot be a solution. But that was the only proposed solution right here. That was the only solution I obtained. So this right here, let me just tell you, you learned this in a previous course, but you've learned that this is called an extraneous solution. Now remember, sometimes we call solution a root or root, extraneous root, extraneous solution or extraneous root, EXTRANEOUS. Now, sometimes you just call this, it really means a false root. So basically what happened was this. Negative 1, now here's why it's a false root. Negative 1 is a solution to this equation here. Okay, or any of these equations. Negative 1 is a solution. Because check. 8 times negative 1 is a negative 8. 4 times negative 1 is a negative 4. Negative 4 plus 4 is 0. And 0 and the negative 8 is negative 8. So negative 8 equals negative 8. Negative 1 is a solution to this. But it is not a solution to the rational equation. See, I had a rational equation. I had variables in the denominator. See, these had variables in the denominator. But when I went from here to here, right here, that's a linear equation with no variables in the denominator. So I can solve this linear equation right here, and I get this solution. But the issue is that negative 1 is not any solution to the original because the original, negative 1, made my denominator 0. The original had variables in the denominator. Okay, so that's why it's called an extraneous root. It's a solution to one of the previous equations through the process, but it's not a solution to the original. Okay, so now here's what you're going to do. Listen carefully. Since negative 1, since you solved all this, you got x to be negative 1, and it turned out to be a restriction, you're going to say your answer, your solution. If that's your blank, you're going to say no solution. Or in my math lab, they may use the symbol empty set. This is a symbol for empty set. So empty set. Okay, so you can say no solution, or you can say the empty set. Does not matter. Just make sure that you don't make it look like a 0. This is a 0 with a slash mark through it. All right, so that's number 1. Okay, number 2. All right, number 2. All right, let's suppose we had this. You had 3 divided by x plus 3 equal 5 divided by 2x plus 6 plus 1 divided by x minus 2. Okay, so, I mean, you can, if you want to, set each denominator equal to 0. So find out what makes each of these equal to 0. There's nothing wrong with that, if that's what you want to do. If you want to find the restrictions first, you can. Notice that this is a rational equation. Remember, rational equation is one or more equation with one or more rational expressions. And there are variables in all of these denominators, so you got to find out what makes this denominator 0, what makes this denominator 0, what makes this denominator 0. Sometimes, just looking at it is easy to determine what makes this 0. You can probably determine what makes this 0. What value of x makes x minus 2 equal to 0? So if you guess 2, you're correct, because 2 minus 2 is 0. But if you can't figure it out like we just did, then set each one equal to 0. So to find your restrictions, set each of these denominators equal to 0. X plus 3 equals 0. And so you get x to be negative 3. So there's one of your restrictions. X cannot equal negative 3. So make sure you say x cannot equal. Don't say x equal negative 3 because you're saying that 3 can be a solution and it can't. You say negative 3 can be a solution and it can't. So you must say x cannot equal negative 3. Here, 2x plus 6 equals 0. So subtract 6. Combine like terms, you get 2x equal negative 6. Divide both sides by 2. And you get x to be negative 3, which you already have. Over here, x minus 2 equals 0. Add 2 to both sides. So another restriction is that x cannot equal 2 because 2 makes this denominator 0. So you have two restrictions here. Those are your restrictions. So it's important that you find all of your restrictions first. Now, what you could have done also, which is going to be important in a little while, to find the LCD, what you may want to do first is factor the denominators before you find the restrictions. Factor your denominators. So right here, see this 2x plus 6? You learned in the previous course that the GCF here is 2, and so you can factor this as 2 times x plus 3. And so you set each factor that has a variable in it equal to 0. So this factor, x plus 2, x plus 3, is equal to 0. Over here, this denominator has two factors. Remember, we talked about factors in the previous course. This has two factors, a 2 and an x plus 3. This factor here doesn't have a variable, so leave it off. You're not going to set that equal to 0, but you're going to set this equal to 0, which you already did. X plus 3 equals 0, you get x to be negative 3. This factor, you're going to set that equal to 0, and you get x equal 2. All right. Now, you got to find the LCD. So remember, we're getting to the point from a previous course where you may need to go back and review some stuff. So to find the LCD, you're going to look at all of your factors. First of all, you're going to factor. Factor first. Factor the denominators. All right, so x plus 3 is already, I can't do anything with it. 2x plus 6, I can factor. You must factor. You cannot leave it as 2x plus 6. You must factor. So you guys say 2 times x plus 3. And then x minus 2, I can't do anything with, so I'm going to leave it x minus 2. So remember, your LCD must include every factor you see. And then remember, in a previous course, you always use the one with the largest exponent. So this factor, there's only one factor of x plus 3. Over here, in this denominator, there's only one factor of x plus 3. Over here, there is none. No factor of x plus 3. So I got to use one factor of x plus 3. Because there's one here, none. The largest of 1, 1, and 0 is 1. Okay, so far, I always put these in parentheses for right now, x plus 3. The next factor I see is a 2. There's no factors of 2 here. One factor of 2 here, none here. So I'm going to use a 2. The next factor is an x minus 2. There's only 1 here. None here, 0 here. So I need 1. Remember, your LCD must include every factor you see. If you see it, you must use it. I see an x plus 3, I must use it. I see a 2, I must use it. I see an x minus 2, I must use it. Now, it got a little bit more complicated in some previous problems we've done in the previous course. So again, go back and review those problems. So there's your LCD. Now, once you find your LCD, now notice the LCD has three factors. And then if you set each of those factors that contain the variable equal to 0, that's what we did here, that's where you're going to find your restrictions. So x plus 3 equals 0, x equal negative 3, that's your restriction. So x cannot equal negative 3 because it'll make the denominator 0, at least one of the denominators 0. X minus 2, I set that equal to 0, so I get x equal 2, that's a restriction. It will make at least one of the denominators 0. Okay, once you find the LCD, just like before what we just did, you'll multiply both sides by the LCD. Notice this is one fraction. On this side, I have two of them, so I'm going to put parentheses over here. So I get 2 times x plus 3 times x minus 2 times the left side. Okay, this times the LCD. So the LCD times the first fraction equal the LCD times the right side. I'll put the right side in parentheses. 5 divided by, and make sure you use the factored part. 5 divided by 2 times x plus 3 plus 1 over x minus 2. So again, make sure you're using the factored part. Make sure you factor the denominators. Then over here, you're going to distribute all this within here. The LCD times every fraction. So every fraction, remember every fraction has to be multiplied by the LCD. Alright, so I'm going to go ahead and distribute this and rewrite this. So I'm going to get the LCD, notice the words, the LCD times the first fraction times the left side, equal the LCD, when I distribute, I'm using distributive property, the LCD times the first fraction. So 2 times x plus 3 times x minus 2 times the first fraction. And the denominator is 2 times x plus 3. Plus the LCD times the second fraction. Okay, so that's where I'm at. And now you're going to reduce. So what's going to happen is this. These x plus 3's divide out. Remember the whole idea of multiplying each of these by the LCDs to clear those denominators, make those ones, make all those ones. And so in the process, make sure that's happening. All right, now here's the situation we have here. So the x plus 3's divide out, but look at what's left. You have this factor times this factor times this factor. So you're going to say 2 times 3 is 6, and then 6 times x minus 2. So 2 times 1 times 3 is 6, so you get 6 times x minus 2. Notice how it looks. Okay, 2 times 1 times 3 is 6 times x minus 2. In parentheses, x minus 2. Equal. Okay, over here, the 2's divide out, the x plus 3's divide out. That's what you wanted. You wanted 1 down here. And notice what's left. 1 times 5 is 5 times x minus 2. Plus, okay, over here, reduce, the x minus 2's divide out, and you're left with this. 2 times 1 is 2 times x plus 3 in parentheses. Okay, so notice what it looks like. So I went from a rational equation, remember this is not linear. This is not linear because I had variables in the denominator, to an equation that is linear. So I'm going to solve this linear equation. So the first thing I'm going to do, remember, you're going to simplify each algebraic expression on each side. So we're going to distribute here, we're going to distribute here, and we're going to distribute here. So let's see what we get. 6x, 6 times a negative 2 is a negative 12, equal 5x minus 10. 5 times a negative 2 is a negative 10. Plus, over here distribute the 2, 2x plus 6. And then you can combine like terms on this side. You can't combine like terms over here. There aren't any like terms, so rewrite this. Over here, 5x and a 2x is 7x. A negative 10 and a positive 6 is a negative 4. Alright, bring the variables to one side. I'm going to go ahead and bring, let's just bring the variables to the left. So I'm going to subtract 7x from both sides. And so I get 6x subtract 7x is a negative x, not a positive x, a negative x. So be careful. Subtract 12, equal, and then 7x subtract 7x is 0, and you're left with a negative 4. Adding 12 to both sides. Since I'm subtracting 12, the opposite is to add 12. Combine like terms, I get 0. Make sure that's what you want. You want to do the 0 here. So I get negative x equal, and then a negative 4 and a positive 12 is 8. All right, remember trying to get x by itself. So I'm going to divide, well, first of all, let's rewrite if you need to. You don't have to, but if you need to rewrite it, you rewrite it. That's really negative 1 times x equals 8. And to get x, to get 1x, a positive 1x, you can divide both sides by negative 1. The opposite of multiply by negative 1 is to divide by negative 1. Notice, make sure you write just like this. Divided by negative 1, divided by negative 1. Negative 1 divided by negative 1 is 1. 1 times x is x, equal 8 divided by negative 1 is negative 8. And then you go back and look at see if that's one of your restrictions. It's not, because the restriction is only negative 3 and 2. Assuming that all of this is correct, I didn't make any errors, that's your solution. So the solution would be x equal negative 8. And you can always go back and check just wherever you see the variable in the original problem. You can check this. So we're checking x equal negative 8. So remember the original problem was this. It was, now you don't have to check, but it was 3 over x plus 3 equal 5 divided by 2x plus 6 plus 1 over x minus 2. So we're seeing x and plug in negative 8. So I get 3 divided by negative 8 plus 3. And we'll see that's going to equal 5 divided by 2 times negative 8 is a negative 16. So negative 16 plus 6 plus 1 divided by negative 8 minus 2. So I get 3 divided by negative 5. And we'll see that's going to equal 5 divided by negative 10 plus 1 divided by negative 10. Negative 2 and negative 8 and negative 2 is negative 10. Since each denominator is the same, I just add the numerators. So here that's going to be 6 divided by negative 10. And 6 divided by negative 10 is a negative 3/5. And that's what you wanted. So negative x equal negative 8 is the solution. All right, number 3. All right, suppose we had 6 divided by, actually let's do 1 divided by x minus 4 minus 5 divided by x plus 2 equal 6 divided by x squared minus 2x minus 8. Okay, so here's a situation where before you find your restrictions, you may want to factor. Because see, this is a trinomial. So you got to remember some stuff from last semester in terms of factoring. You've spent quite a bit of months of that particular course in factoring. So to factor this right here, now these I can't factor. They're linear factors, so I can't do anything with them. And the G7 in both cases is 1. But here, I can factor this. That's going to be x. Remember, use the reverse FOIL. And that's going to be x minus 4, x plus 2. And always check yourself. X times x is x squared. Remember the FOIL. The outer is 2x. The inner is a negative 4x. And when I add them up, I get negative 2x. And negative 4 times a positive 2 is a negative 8. Now, usually what's going to happen is that when one of them is a trinomial, and the other linear, at least one of these linear factors will be one of these. So that's not always true, but you can always check that. Okay, so I factored the denominators. First thing we do is factor your denominators. Now let's find the restrictions. So remember, to find the restrictions, you set each of these factors equal to 0. And sometimes you can just do it in your head. Sometimes you may need to write down. So I want to know, where's x minus 4 equal to 0? That's the question. Well, x minus 4 is equal to 0 when x equals 4. So there's your restriction. One of them cannot be 4. So make sure you say x cannot equal. Don't say x equal. You're going to say x cannot equal 4. The next one is x plus 2. Where is that 0? Well, to get x by itself, you can subtract 2. Combine like terms, I get x to be negative 2. So there's your other restriction, x not equal negative 2. Then you go to the next one. The first factor I see is x minus 4. We've already dealt with that. That's this one. The next factor I see is x plus 2. I've already dealt with that. That's this one. So you're done. Those are your restrictions. So now we're going to solve this. So we've got to find the LCD. So the LCD now, every factor you see has to be in the LCD. Every factor you see has to be in the LCD. That's something you learned quite a bit of last semester. So x minus 4 is a factor. I got to use it. Now, the question is, how many do I need? Well, there's only one here, none here. There's 0 factors here, and there's 1 here. So I got to use just one of them. Now, if that was x minus 4 squared, remember, if that was a squared right here, then you would use 2 of them. You always use the one with the largest exponent, the one that occurs the most. So 1 factor, 0, 1. The largest of 1, 0, 1 is 1. So you need just one of them. The next factor I see is x plus 2. There's 0 here, 1 here, 1 here, so I'm going to use 1. And that's it. The next one is x minus 4. You've already taken care of it. The next one's x plus 2. You've already taken care of it. So there's your LCD. X minus 4 times x plus 2. Once you find the LCD, though, remember you're going to multiply both sides by it. So it's just like what you did here. Remember all these steps. So quite a few steps involved. So once you find the LCD, which was this right here, you multiply both sides by it, and then you went through the process. So I'm going to go ahead and put that here. So that's going to be the LCD, x minus 4, x plus 2, times, now since this side, since the left side is 2 fractions, put that in parentheses, times the left side, just like that, equal the LCD times the right side. Now, since that's 1 fraction, I'm just going to leave it as 6 divided by, but make sure you write it in factored form, the denominator. X minus 4, x plus 2. Alright, and then I'm going to, what you have to do now is remember to distribute this, so distribute that LCD. So I get x minus 4 times x plus 2 times the first fraction minus x minus 4 times x plus 2 times the second fraction. And you could have done this as well. You could have said plus a negative 5. Okay? But I'm just going to leave it like this for right now. Okay, and then that's going to equal over here. Let's go ahead and reduce this. These divide out already. These divide out. And so you get 1 times 1, and then 6 over 1, which is just 6. So you're just left with 6. Okay, reducing over here, the x minus 1s divide out. Remember, that's the whole idea is to get 1s down here. But 1 times x plus 2 times 1, so 1 times 1 is 1. 1 times x plus 2 is just x plus 2, without parentheses. Alright, now be careful here, because it's subtraction, so be careful. So that's x plus 2, those divide out. Alright, now be careful. So that's, you're subtracting whatever this is right here. So 5 times 1 is 5, so you're subtracting 5 times x minus 4. Notice how it looks, so you got to be careful. You're subtracting, so cover this up, and then 1 times 5, this is 5, 5 over 1 is 5, 5 times 1 is 5, times x minus 4. That's what this is. And that's going to equal 6. Alright, now you got to get rid of these parentheses right here, so you can use the distributive property, but remember you're going to distribute the negative 5. Not 5, negative 5, because remember subtraction means the opposite, means adding the opposite, adding a negative 5, so distribute the negative 5. So I get x plus 2 minus 5x, a negative 5 times x is negative 5x, a negative 5 times negative 4 is a positive 20, equals 6. Combining like terms, x and a negative 5x is a negative 4x, 2 and a positive 20 is a positive 22, equal 6. So negative 4x plus 22 equals 6. Subtracting 22 from both sides, I get, combining like terms, I get negative 4x equal negative 22 and a positive 6 is a negative, let's see, what's that, 16? Negative 16. And then to get x by itself, we're now multiplying x by negative 4. The opposite is to divide by negative 4. Negative 4 divided by negative 4 is 1. 1 times x is x. Negative 16 divided by negative 4 is a positive 4. All right, so we got x to be a positive 4. That's my proposed solution. But remember, positive 4 makes this denominator 0. It even makes this denominator 0. Remember, that's a restriction. So I can't use it. That was the only one I got. So now, remember, that's right here is an extraneous root. Now, you don't have to write the word extraneous root, but that's what you got to think of. Hey, this is an extraneous root, meaning it satisfies this equation here and this equation here, but it doesn't satisfy the original because when I plug in 4 into x, it makes this denominator 0 and this one 0. And I can't divide by 0. So you're going to say no solution. So the answer, you're going to say either the empty set or you can say no solution. Okay, so this is going to be part, this is a long video, so it's like 36 minutes. So I'm going to do a couple more, but I'm going to do that in another video. So let's go ahead and stop this one. So this is going to be, this is part 3, and there's going to be another part of part 3 in a little while where I'm going to just do 2 more problems. So let's go ahead and just do that.